Okay, so our last example, example 3, focuses on factoring by grouping. And several of you have already been exposed to what factoring by grouping is. So for some of you, this may be a review. But for some polynomials, we can factor by grouping pairs of terms that have same common monomial factors. So what does that mean? In letter E, if we look at this letter E in example 3, we'll notice that our first term, x squared, is being multiplied to the group x minus 1, minus my second term, 9, is being multiplied to the same group, x minus 1. If we're in a situation like this where both of our groups are exactly the same, we can group our two outside values together. So this would give us x squared minus 9. And we can then group our other, group the x minus 1 as one group. So we're going to include x minus 1. We're going to write it just once. So we're taking our two outside values, we're including that as one group, and then the x minus 1 just becomes its own group because it's exactly the same. So at this point, you just group them together. If there's any groups that can actually be factored a little bit further, we're going to do so. So the x squared minus 9 can be broken down one more time. We know that to be x minus 3, x plus 3. And then the x minus 1 can't be broken down at all, so we're going to write x minus 1. It's in simplified form. So letter E can be broken down into 3 groups. In letter F, this is a little bit different. Letter F is actually the step before letter E. Letter E, I actually pushed that through a little bit just to show you how you actually go about grouping them. But in letter F, the first thing we notice is that we want to solve. So solving means at the very end anyways, we're going to be setting all of our groups equal to 0. But before that, we need to get our values into groups first. So we need letter F to look similar to what letter E was like before we pulled the outside values together. So in this case, grouping, what you want to do is you want to take your first two terms and group them together, your second two terms and group them together, and you want to pull out what they both have in common. So x to the third minus 2x squared, both of these terms have an x squared in common. So the x squared gets pulled out. If I pull out an x squared, that means I have one x that's left over inside, minus, the x squared here got pulled out, so I have a minus 2 left over. So that's my first two terms grouped together. Minus, because I have a minus here, I'm going to look at these two values. Negative 16x plus 32. What number can get pulled out, or what value can get pulled out of both of these? We can actually pull a 16 out. If we pull a 16 out of both of them, the negative 16 gets pulled out. I have an x left over, plus 32. So if I had pulled that out, since this is negative, to be distributed evenly to get the positive 32, I have to have a minus 2 on the inside, because negative 16 times negative 2 gives me a positive 32. So just be careful of that. Equals 0. In this case, because I pulled out in the groupings what they each have in common, because these two groups, and only because these two groups are exactly the same, I can continue the steps with factoring by grouping. And we do that just like we did in letter E. The x squared minus 16, my two outside values get pulled together. It gives me x squared minus 16. And because both of these groups match exactly, I can write it just once for x minus 2. Again, I still have the equals 0 at the end, but I'm not completely finished because x squared minus 16 can be broken down one more time. And that happens by taking x minus 4, x plus 4. And obviously x minus 2 can't get any more simplified than that. The last step in letter F is to solve. Solve just means that we find the x values that sets each group equal to 0. So if I set each group equal to 0, so that's my first group, x plus 4 equals 0, x minus 2 equals 0, and I solve for my x's, I would get x is equal to, this would give me a positive 4, this minus 4 would give me a negative 4, and I would add the 2, so this would give me a positive 2. My leading degree here was x cubed, which means I should have 3 values or 3 answers for x, even if they are imaginary, but in this case they happen to be all real numbers. 4, -4, and 2 are my answers for letter F. Again, take some time now to review letter E and letter F if you need to, and then work on numbers 9 through 12 and see how far you can get for tomorrow's class. 2 of them have you solving for x, the other 2 are just simple factoring.